So good evening, Devan. I think we can start the class. Can you able to see my screen? Is my screen visible to you? Yes. So today I will not be able to switch on my video since I do not have power in my place. So once the power supply comes here, I'll just turn on my video. Okay. Okay. Fine. Okay. So let's start with the class today. So today we are going to see a new topic called biomolecules. Okay, you might have heard of this lesson. Just a second. Yeah. So today we are going to start with the biomolecules. And what are biomolecules? So the whole earth is made up of mainly human. Yes, Veera. Good evening. The whole earth is made up of human and plants. Okay. So humans also grow and plants also grow. And after growing, what they are doing, they are reproducing, and they are reproducing, and they are giving birth to their newborns. Okay, so the whole living system is made up of biomolecules. Whole living system is made up of the biomolecules. So, what are biomolecules? What are the biomolecules? They are carbohydrates, proteins, nucleic acids, and lipids. So these four, they'll interact with each other. They will interact with each other and they constitute the molecular logic of the whole life process. Okay. So in this lesson, we are going to discuss about carbohydrates, proteins, nucleic acids, and some more are there. Vitamins, hormones. Will deal with all those biomolecules. Okay. So is that clear? So you can see the structure here. So these are the biomolecules which are present and which constitute the molecular logic of the whole life process. Got it? So in today's class, we are going to see the introduction and classification of carbohydrates. Mainly, we are going to deal with monosaccharides of carbohydrates today. And in monosaccharides, glucose and fructose are going to get covered. Okay, so these three are the topics that we are going to cover for today. Got it? So moving on to the introduction and classification of carbohydrates. So for carbohydrates, the main sources, they are primarily produced by plants. They are primarily produced by the plants. Carbohydrates are primarily produced by the plants. Got it? And carbohydrates are called as hydrates of carbon in olden days. So in olden days, how do they call this? Hydrates of carbon were called as carbohydrates. So what are hydrates? Hydrates are H2O, water molecule containing system. So hydrates of carbon. So H2O and carbon atom will be there in the system. Got it? So the general formula for hydrates of carbon or carbohydrates is CX and H2OY. So this was the formula for in accordance with the olden definition. Got it? So those molecules which are falling under this particular formula, they are called to be a carbohydrate. So let us see an example to understand this. So glucose is taken here. So C6H12O6 is the molecular formula for glucose. And what is the X value? X value is 6 here. And what about Y value? Y is also, what is the formula? It is C6. And we can write H2O 6, right? So 2, 6 becomes 12 and 6 oxygen. So X value is also 6 and Y is also 6. So the compounds which are falling in this formula, they are called as carbohydrates. So glucose is an example. Okay. So and some more exceptions are also there for this. Acetic acid is the exception. So in acetic acid, how many carbon we are having? We have 2 carbon and 4 hydrogen and 2 oxygen. So acetic acid is a carboxylic acid. It is not the hydrates of carbon. It is an acid, carboxylic acid. Acid cannot be a carbohydrate, right? But you see, it is fulfilling this formula. That is, it is having, it is satisfying CX and H2OY formula. But it is not a carbohydrate. It is an acid. Okay, it follows this formula, but it is not a carbohydrate. But you see, Ramnose is taken again. Ramnose formula C6H12O5. It does not fall under this formula, but it is a carbohydrate. Acetic acid is not a carbohydrate, but it is following the formula. Ramnose is a carbohydrate, but it doesn't follow the given formula. So, what to do now? Reactions have shown that carbohydrate contain specific functional groups. Reactions have shown that carbohydrate contain specific functional groups, and these carbohydrates are also called as saccharides. They are also called as saccharides. Since we have certain exceptions like this for carbohydrate, what they are saying, hydrates of carbon is not the correct definition for carbohydrate. So there is some other definition, correct definition for carbohydrate, and that definition is, we'll go for the next slide. Have you noted this? Have you noted this, my dear? And yes, Devan. Okay, I'll go for the next part. So is this clear, right? Okay, so what are carbohydrates? What is the correct definition for carbohydrates? They are optically active polyhydroxyaldehydes or ketones. So what is optically active? The compound which rotates the plane polarized light in clockwise direction as well as in anti-clockwise direction. They are called as optically active compounds, right? So you might have studied this in some basic concepts of organic chemistry in your 11th class. So optically active compounds are the compounds which rotates the plane polarized light in clockwise as well as anti-clockwise direction. Otherwise, the compound which contains chiral center is called as optically active compounds. So what is a chiral center? A center which is attached to four different atoms or groups is called as chiral center. So if a compound contains chiral center, then that particular compound is optically active. Okay, so optically active polyhydroxy. So what is hydroxy? Hydroxy means OH. Polyhydroxy means what? More number of, just a second. Yeah. So polyhydroxy means more than two or three OH group containing compounds. Okay. So the compound should contain chiral center as well as it should contain more number of OH groups present in it. Okay. And also an aldehyde group should be there or a ketone should be there. Then only that particular compound is called. Good evening student. Good evening. You're Sandeep, right? From Vishakhapatnam. The person who is behind the 12th class is Sandeep only, na? Okay, okay, okay. Okay, good evening, Sandeep. So carbohydrates are optically active polyhydroxyaldehydes or ketones. Got it? So here you can see the structure of a carbohydrate. So these two are the carbohydrates, and the first compound you can see. So each carbon, not all the carbon, we have 6 carbons in the first structure. Okay. So the first structure is glucose and the second structure is fructose actually. So in both the structures, we have 6 carbons. Got it? But these 4 carbons are optically active carbons. Why? Because those 4 carbons are attached with 4 different atoms or groups. So if I take this particular carbon, left side we are having H, right side we are having OH, and the bottom we are having in the third position, the whole big group is there, and in the fourth position is occupied by aldehyde part. Okay, so we have chiral centers over there in the compound, and also we have 4 OH group present there. So it is an optically active polyhydroxyaldehyde, which is called as glucose. So CHO is the aldehyde part, you can see. And in the second compound, what is a functional group present? We have R, C double bond O, R, right? So this is an R group, this is R, this is CO, and this whole part is R. So it is an optically active polyhydroxy ketone. Got it? So they are called as carbohydrates, and sweet carbohydrates are called sugar. So in sugar cane, we have sucrose. Sucrose is a carbohydrate. So and it is a sweet carbohydrate. And in milk, you can see, right? What is the name of the carbohydrate present in milk? Just a second. Just a second. So what is the name of the carbohydrate present in milk? It is lactose. So lactose is present in milk. Okay, sucrose and lactose, they are also carbohydrates. Got it? So is the carbohydrate part clear? Definition, correct definition for carbohydrate is clear to you? Shall I move on to the next slide? For both of you. So Sandeep, we are dealing with a new chapter called biomolecules. Got it? And biomolecules are carbohydrates, vitamins, um, nucleic acids, lipids, etc. And I am dealing with the carbohydrates here. I started with the carbohydrates. So carbohydrates are called as hydrates of carbon in the olden days, but now since some of the groups are falling into that category, I'll show you the slide, just a minute. So since many compounds are falling into that particular formula, but they are not called as carbohydrate. So the correct definition for carbohydrate is not hydrates of carbon. They are optically active polyhydroxyaldehydes and ketones. Got it? So that is what I have been explaining so far. Okay. So I'll go for the, yeah. So I'll go for the classification of carbohydrate. Okay. So the classification of carbohydrate is okay. No problem. No problem. So carbohydrates are classified into two. First is on the basis of their behavior of hydrolysis. Second classification is on the basis of reducing nature. Okay. So based on the behavior of hydrolysis, it is classified into three. The first is monosaccharide, oligosaccharide, and the last one is polysaccharide. Okay. So based on the reducing nature, they are classified into two. The first is reducing sugar and the second one is non-reducing sugar. Okay. We'll discuss one by one. You can just take the screenshot of it or make note of it. If you have done it, just type S or give me a thumbs up so that I'll go for the next slide. Excuse me. So how many classification we have? We have two different classification. So we are going to see one by one. Yes. Thank you, Devan. I'll go for the classification on the basis of behavior of hydrolysis. So on this, three divisions are there. So what are monosaccharides? So monosaccharides on hydrolysis cannot be hydrolyzed further to give a polyhydroxyaldehyde or ketone. Means you cannot hydrolyze a monosaccharide. What is hydrolysis? What is hydrolysis? Reaction with water, right? A monosaccharide will not react with water. It cannot be hydrolyzed to give a polyhydroxyaldehyde or ketone. If it is like that, then they are called as monosaccharide. And what are oligosaccharides? So you can see the example. Glucose is an example for monosaccharide. Fructose is an example. And the ribose. These three sugar molecules or these three saccharide molecules are the examples of monosaccharide. Then coming to the oligosaccharide, they undergo hydrolysis. And on hydrolysis, they give 2 to 10 monosaccharide units. On hydrolysis, they give how many? 2 to 10 monosaccharide units. Okay. So what are the examples for that? Sucrose, maltose, and lactose is also a oligosaccharide only. And polysaccharide. Polysaccharide also undergoes hydrolysis and they yield a very large number of monosaccharide units. Got it? That is, they will yield more than 10 monosaccharide units on hydrolysis. Okay, they are called as polysaccharides. So the examples are starch, cellulose, and glycogen. Okay, so this is about the classification on the basis of behavior of hydrolysis. If a compound cannot be hydrolyzed further, they are mono. If they yield 2 to 10 on hydrolysis, they are oligo. If they yield more than 10, they are called as polysaccharide. Okay. So we are going to discuss about glucose, fructose, and sucrose, maltose, starch, cellulose, glycogen in the upcoming slides. Okay. Shall I go for the next part? Do you have any doubt here? Shall I go for the next part? Next slide. Okay. So, yeah. Now, the second classification is on the basis of reducing nature, right? They were classified into reducing and non-reducing sugar. And what are reducing sugar? So, the compound which reduces the filling solution and tolerance reagent. So, who are these two reagents? Fillings and tolerance we have discussed in the carboxylic acid and aldehydes and ketones lesson, no? So, the aldehydes basically gets oxidized to carboxylic acid on reaction with filling solution and tolerance reagent. So those compounds which reduce those two, they are called as reducing, and which do not reduce those two are called as non-reducing sugar. So this is a filling solution, and to this solution, if I am adding the particular carbohydrate, if I am on adding this particular carbohydrate, if no change occurs, if there are no change occurs, then it is called as non-reducing. And to the same filling solution, if I add a particular carbohydrate and if I am getting red color of that filling solution, and if the color changes to red, then we can say that the given compound is a reducing sugar. Got it? So all monosaccharides will fall under this category. And sucrose is the only non-reducing sugar which falls under the disaccharide compound. Okay, clear? Clear? Yes. Thank you. So let's go with the monosaccharide, that is glucose. Glucose, fructose, and ribose were the examples of monosaccharides, and we are going to discuss in detail about the glucose and fructose. So, moving on to glucose. So, monosaccharides on the basis of number of carbon atoms and on the basis of functional groups present, they are classified. Okay, first on the basis of number of carbon atoms, it is classified like this. If 3 carbon atoms are present in a particular compound, then it is called as triose. And if aldehyde group is present in that compound, it is aldotriose. And if ketone functional group is present, it is called as ketotriose. Okay, so based on number of carbon as well as based on functional group. So if 4 carbon atom is there, then it is tetrose. Aldehyde present means it is aldotetrose, ketotetrose. And for 5 carbon, it is aldopentose and ketopentose. And for 6 carbon system, it is aldohexose or ketohexose. So glucose falls under which category? So can you tell me? We have seen the structure of glucose. No, glucose contains aldehyde group and 6 carbons were there. What is the name of general name given to that? Aldehyde group is present there in glucose and it is a 6 carbon containing compound. So it is called as aldohexose. It is called as aldohexose, and fructose is a ketohexose. In fructose, ketone group is there and 6 carbon containing system. So it is a ketohexose. Got it? Clear for both of you? Shall I go for the next slide? Shall I go for the next slide, students? Yes. So monosaccharide. So what is the functional group present in glucose? It is an aldehyde group. And what is the molecular formula of this glucose? It is C6H12O6. Okay. So it is a very familiar formula. You might have studied in your biology part also. So the same lesson is here in chemistry. Only slight modifications will be there. So it is very easy for you all. So the molecular formula for glucose is C6H12O6, and the major source of glucose is nature only. So in nature only, we are finding this glucose at a very major composition. So in ripe grapes, you can find the glucose. Okay, and in honey also you can find the glucose present in it. Okay, so these two are the nature containing compounds. No, so the nature consists of glucose. Okay. And how to prepare this glucose? So there are two preparations. So what is the first one? The first is from sucrose. Sucrose you can get it in cane sugar, right? So what is the formula for sucrose? Can you let me know in the chat box the formula for sucrose? Do any of you know the formula for sucrose? No? C12H22. Yes. Yes, that's correct. Good. So C12H22O11 is sucrose. So we are going to hydrolyze this sucrose. So make it to react with water and heat it in presence of dilute HCl or dilute H2SO4 in alcoholic solution. Treat this with an mineral acid, okay, and heat it. You will get two compounds. One is glucose and the other one is fructose. Both have the same molecular formula, but they differ only in the functional group. Okay, glucose contains aldehyde and fructose contains ketone. Both of them have the same molecular formula. They are isomers. Okay, functional isomers. And the second preparation of glucose is from starch or cellulose. What is the formula for starch? May I know the formula for starch? If you would have heard of the formula for starch, just let me know in the chat box. Okay. So the formula for starch is C6H10O5 N times. Yeah. Yes, Sandeep. You have left the N, but your formula is correct. Yes. So C6H10O5 N times is the starch, and starch on hydrolysis in presence of same mineral acid, but you see the reaction condition. Here we are giving a specific temperature. Okay, heating it to a specific temperature, that is 393 Kelvin, and 223 atmospheric pressure is given to this starch. Only at this particular reaction condition, starch will produce a glucose. N molecules of glucose is being formed, and no byproducts are formed here like it is formed in the previous case. In previous case, we are getting fructose and all, no. So no such byproducts here. Only the whole molecule is the major product is only the glucose. Got it? So from starch or cellulose, you can get the glucose using this particular reaction condition. So these two are the preparation of glucose. So very important. Only two preparation we are having. Those two preparations are very important. You have to study the reaction conditions and all the formulas. You should be thorough. Okay, got it? Shall I go for the next one? Shall I go for the next slide? You guys are noting down the reactions or taking the screenshot? May I know whether you guys are noting down the reactions or taking the screenshot? Noting? Oh yeah, that's great. That's great. Fine, fine. I'll go for the structure of glucose. Screenshot. Okay, whatever might be the way you're following, just try to understand, and after the class you just make a note of it. Only if you maintain your own notes, you can use it for the future purpose. Okay, for revising purpose. If you have the screenshot of it, then at last it will trouble you only. Okay, no problem, you can take the screenshot during the class, but once the class gets over, you make a note of it. Okay, take down the notes of the class and keep it. Okay, Devan? Got it? Yes. Okay. So the structure of glucose is studied by two different ways. One is the open chain structure, the other one is cyclic chain structure. Cyclic chain in the sense it is a closed chain. Okay. So open chain structure and the cyclic chain structures are the two different structures of glucose. So moving on to open chain structure of glucose, let's see the molecular formula. It is C6H12O6, right? And this is the structure. So first carbon contains this aldehyde group, and from second carbon till fifth carbon we have CHOH group attached, and the sixth carbon is CH2OH. So this is the open chain structure of glucose. And now we are going to see some chemical reactions of glucose. So the reactions which we are going to see now, they are very important. So concentrate more on it. The first reaction is the reaction of glucose with HI, hydrogen iodide. So we are taking the glucose molecule and treating it with hydrogen iodide, and we are going to heat it. So what is going to happen? We are getting a hydrocarbon. We are getting an N-hexane. So why we are getting, yeah, good. Why we are getting N-hexane? Glucose contains 6 carbons, right? So that's why we are getting a 6 carbon containing alkane. So this reaction shows that, the conclusion from this reaction is all the 6 carbon atoms in the glucose molecules are linked in a straight chain. They are linked to a straight chain. There is no branching in glucose molecule. Like the glucose molecule is attached, all the 6 carbons are present in the straight chain manner, and there is no branching. Six carbons are not branched like this. Okay, system is not like this, it is like this. So this is the conclusion the scientist got by the reaction of glucose with HI. Okay, both conclusions and reactions are important. Shall I go for the next reaction? Shall I go for the next reaction? Yes. So coming to the next reaction, it is with the hydroxyl amine. The formula for hydroxyl amine is NH2OH. This we have seen in the aldehydes topic itself. So can you let me know the name of the product we get from here? Or can you just let me know what will happen here? When aldehyde reacts with NH2OH, what happens? We have already come across this reaction under reaction with ammonia. Yes. Yes, Sandeep. Great. So oxane, we get an oxane. So how does this produce? So we have the CHO is like this, no? C double bond O, H is the aldehyde part. And oxygen from aldehyde and H2 from hydroxylamine goes out as H2O. And what do you have to do? Connect this nitrogen derivatives in aldehyde lesson. Yes, yes, reaction with ammonia and its derivatives we have studied. No, yes, under that topic only we have discussed this. Good, good. So, I think you guys are revising at your home after the class gets over. That's really great. So, consistency is very important to clear and get good marks in all the competitive examinations. Okay, every day you have to spend some time for your NEET and JE preparations. Got it? So I think Sandeep is a NEET aspirant. And what about Devan? Sandeep, am I right? You are a NEET aspirant, right? Devan is? Yeah, yeah, J. Okay, okay, no problem. So good, good. So okay, okay, okay. Okay, okay, very. Okay, okay, fine. So we are getting an oxime. We are getting an oxime from the given reaction. And next is the reaction with HCl. So can you tell me The name of the product on reaction of glucose molecule with HCN. Can you tell me? Can you tell me the name of the product? This also we have seen under cyanohydrin. Yes, very good, very good. So this is the cyanohydrin, and how do we get this? We have C double bond O H, right? And here is the remaining whole part. So we break this bond, we add the H to the oxygen and the CN to the carbon. So we are getting a cyanohydrin from the glucose on reaction with HCN. So these two reactions shows that the presence of carbonyl group in the glucose molecule. Okay, these two reactions, because in these two reactions you can see the reaction is occurring only at the aldehyde part. Okay, so alcohols part, the carbon number 2 till carbon number 6, they are not disturbed, they remain same in the product. Reaction occurs only at the first carbon, which is aldehyde, and it is a carbonyl group. So these two reactions are the proof, okay, for the presence of carbonyl group in glucose molecule. Okay, shall I go for the next reaction? Shall I go for the next reaction? If you just type yes, I'll go for the next reaction. Yes, thank you, Devan. Thank you so much. So completed. Okay. So the next reaction is the reaction with mild oxidizing agent like bromine water. So we are taking the glucose and we are treating it with bromine water. And on a reaction with bromine water, what happens here? The CHO group is getting converted to COOH. Aldehyde is getting oxidized to carboxylic acid. And this is an oxidizing agent which is called as mild oxidizing agent. Okay, it is called as mild oxidizing agent and the name of the product is gluconic acid. The name, structure, the conversion and the reagents that are used, everything is very important. Okay, it is a mild oxidizing agent which oxidizes an aldehyde to gluconic acid. Got it? So what is the conclusion from this reaction? Carbonyl group is present as an aldehydic group. If the carbonyl group is some other component, then we would have not arrived at this gluconic acid. We would have not get carboxylic acid. So we get carboxylic acid only on oxidation with aldehyde, right? So that is the conclusion here. Presence of aldehyde group is the conclusion again. And next reaction is acetylation with acetic anhydride or acylation with acetic anhydride. Both are same only. So we are taking the glucose and treating it with acetic. What is the formula for acetic anhydride? Formula for acetic anhydride is CH3 C double bond O O C double bond O CH3, right? So this is the formula and our glucose molecule is treated with this. So here what happens? So the OH from all the alcohol part is coming out as acetic acid. Okay, 5 moles of acetic anhydride will react with the glucose. And since we have 5 OH group in the glucose molecule, all the 5 OH will be removed with CH3CO as CH3COOH. Okay, and the remaining OCOCH3 is getting attached to the carbon from second carbon till sixth carbon. And at last, what we are getting? We are getting an acetate group attached to the system. So how many acetate? 5 acetate. That's why it is called as pentaacetate. And the molecule is called as glucose pentaacetate. Molecule is very stable. And here in this reaction, you can see the reaction occurs at the alcoholic part containing carbon. It is not occurring at CHO. It is not occurring at the aldehyde part. So what is the conclusion? There are 5 OH groups attached to the different carbons is the conclusion. Okay, got it? Shall we go for the next reaction? Shall I go for the next reaction? Yes. Yes, thank you, Sandeep. So the next reaction is oxidation with nitric acid. Okay, so we are taking the glucose molecule and we are oxidizing it with bromine water. So glucose and oxidation with bromine water, what happens? We get gluconic acid. This is the reaction which we have seen in the previous slide. And this gluconic acid on further oxidation with nitric acid, what is the formula for nitric acid? It is HNO3, right? The formula for nitric acid is HNO3. And on reaction with HNO3, it forms saccharic acid. So see the formula. Here oxidation occurs in the OH group containing carbon. That is a last carbon. It is last carbon is getting oxidized to carboxylic acid. So what is this? CH2OH. CH2OH means it is a primary alcohol. So primary alcohol is getting oxidized to carboxylic acid on reaction with HNO3, but the secondary alcohols. So all these 4 carbons are secondary carbons, right? CHOH. Secondary alcohols are not undergoing the oxidation with HNO3. Okay, got it? So what is the conclusion? The presence of primary alcoholic group in glucose molecule is the conclusion from this particular reaction. Okay, if a molecule contains 2 COOH group at first and last carbon, then it is called a saccharic acid. And if only one COOH is there in the first position, it is gluconic acid. Okay, got it? So these are the 6 chemical reactions of glucose. So what is the first reaction? It is a reaction with HI. And what is the second reaction? It is with NH2OH, hydroxylamine. And what is the third reaction, students? What is the third reaction we have seen? Can you tell me the third reaction? Reaction with HCN. What is the fourth reaction? What is the fourth reaction? Oxidation with mild oxidizing agent. And fifth reaction is reaction with acetic anhydride, which leads to the formation of pentaacetate. And the sixth reaction is oxidation with nitric acid. Okay. So all the 6 reactions are very important and you have to study the conclusions that we are getting from each reaction. Okay. So do you have any doubts here in the chemical properties of glucose so far? No doubt? Okay. So now let's study the open chain structure of glucose with the D and L configuration. Okay. So here is the structure of glucose. And in this structure, we have 6 carbons. And this is carbon number 1. This is carbon number 1, carbon number 2, carbon number 3, 4, 5, and 6. Okay. So the last before carbon is having OH group and H group. And in the structure, the OH group is present in the right side in this molecule. Okay. If the OH group, last before carbon's OH group is present at the right side of the molecule, then the particular compound configuration is called as D configuration. And it is called as D plus glucose. I'll give you the meaning for that plus, okay, in few minutes. So the name is D plus glucose. So D represents the OH group on the right hand side, and this positive, this plus symbol represents that the particular compound will rotate the plane polarized light to clockwise direction. Okay. You might have studied this optically active concept in your organic chemistry lessons. Okay, we used to take a compound, and that compound, if it is allowed to pass through the plane polarized light, then if that particular compound, if it rotates that plane polarized light to two direction, that is, it will rotate through clockwise as well as it will rotate through anti-clockwise. If this particular compound rotates this plane polarized light to two different direction, then they are called as optically active compounds. Okay, how do we get this plane polarized light? We pass the ordinary light. So this is the ordinary light. When we pass this ordinary light in a polarizer, we get a plane polarized light. This is the ordinary light and this is your plane polarized. Yeah, dextro-levo-rotatory. Yeah, I'll discuss about that later, okay? So when we pass this ordinary light through a polarizer, this is the polarizer, and this ordinary light will become plane polarized light. Plane polarized light will give light only in one direction. Ordinary light will give light in all the directions, right? So plane polarized light will give the light only in. Yes, yes, Sandeep. Do you have any doubt? Yeah. Do you have any doubt? You have raised your hand. Oh, you want me to explain again? Okay, I'll explain. Listen, first we are taking an ordinary light. Got it? Ordinary light gives light in all the directions. Yeah, I'll tell you. And if this ordinary light is passed through a polarizer, then the light becomes a plane polarized light. So what is a plane polarized light? The that plane polarized light will give the light only in one particular direction. You can see here, it is giving only in one direction. One is going upward, the other one is towards down. Only one direction, the light is getting formed. And if this plane polarized light is passed through a compound, okay, and let me take the given compound as an chiral compound. Chiral compounds are optically active. Chiral compounds are optically active. If I pass this particular plane polarized light in an optically active compound, this optically active compound will rotate this plane polarized light in two different directions. Okay? Because two different compounds are present there. So a group of set of compound will rotate it in clockwise direction, and those compounds are denoted as plus, and some few compounds will rotate that plane polarized light in anti-clockwise direction. Those are represented by minus. Got it? Got it? And if the compound is optically inactive, we would not see the two different set of rotations. Plus minus won't be there because only one type of compound is there. It will rotate the light only in one direction. Either it will be in clockwise or it is in anti-clockwise. Got it? So only optically active compounds will rotate it in two different directions. Yes. So now here glucose is represented by D plus. So what is the meaning for this plus now? This glucose will rotate the plane polarized light in clockwise direction. Got it? That's why we are representing it as D plus glucose. And here you see, yeah, right side, since OH is present on the right side, it is called as D. Okay. And in the second compound, OH is present on the left side. The last before carbon OH is there in the left side. So it is represented by L. It is represented by L and it is called as L minus glucose. So L represents that OH is on the left side. The minus denotes that the given compound will rotate the plane polarized light to anti-clockwise direction. Anti-clockwise direction. Okay. D and L represent the position of OH group, that is right and left, and plus and minus denotes the rotation of plane polarized light, that is clockwise and anti-clockwise. Got it? If you have any more doubts here on this, you can type it in the chat box and clear it. Okay. Shall I go for the next topic? Next slide. Hope this is clear to you. Shall I go for the next slide? Yes. So there is a question to you all. Glucose is a reducing sugar, explain. Glucose is a monosaccharide, but it is a reducing sugar. How to explain this? It is a reducing sugar because it reduces filling solution and tolerance reagent. Okay. So what is this? This is a filling solution. So on adding the solution of glucose to it, the solution turns red. If a solution turns red, then the particular compound, that particular solution is a reducing sugar, right? So from the color changing only, they are telling that glucose is a reducing sugar. So why the color change happens? There is a free aldehydic group present in the structure of glucose. So basically, Fellings and Tollens, what they do, what is the role of filling solution in Tollens reagent? The role of filling solution in Tollens reagent is the conversion of, presence of CHO. The conversion of RCHO to RCOO minus, right? So since we have aldehydic group there in the glucose molecule, that aldehyde CHO will be converted to a corresponding carboxylate ion, and that's why the color is changing. Yes, Sandeep, correct. So that's why color changes occurs, and glucose is said to be a reducing sugar. Got it? If a substance or if a compound contains free aldehyde group, then it will reduce both fillings as well as tolerance reagent. Got it? And they are called as reducing sugar. Fine. So now coming to the cyclic structure. So far we have discussed about the open chain structure of glucose, that is D plus glucose and L minus glucose. Now coming to cyclic structure. How to get the cyclic structure from the open chain structure? So you see, listen carefully. So we are having the C double bond O H aldehyde group present there at the first position of this system. And if this compound does not give Schiff's test, and there is no addition product with NaHSO3, and there is no reaction of pentaacetate formation with hydroxyl level, okay, then that particular structure is called a cyclic structure. Cyclic structure of glucose will not give all these three. Okay. What does it indicate? It indicates the absence of free CHO group there in the cyclic structure. It indicates the absence of free. In open chain structure, we have free CHO and the reaction occurs at the CHO. And that's why we are getting the product. Cyclic structure doesn't have this free CHO. So the reactions which has to be occurred at the position of aldehyde group, they will not occur. And those are these three reactions. Okay. So the cyclic structure of glucose exists in two different crystalline forms called alpha form and beta form. And the open chain structure does not explain this alpha form and beta form behavior. That's why we are moving to the cyclic structure of glucose. Shall I move on to the cyclic structure of glucose? Yes. So listen, this is the structure, open chain structure. The last before carbon OH you have to take. So oxygen is there. Oxygen contains two lone pair of electrons, and one of its lone pair, we see both of you see the lone pair of electron which is there on the oxygen will act as a nucleophile, and it will go and attack the carbonyl carbon, which is electrophilic in nature. Okay. And the pi electrons will be shifted to oxygen. So what we get? We get O minus there, and that O minus will come and take the hydrogen which is attached with this oxygen. So basically what we get? we get two forms. So the first structure looks like this. There is a ring formation happening. So this particular carbon is forming the bond with oxygen. So you see, first carbon is forming the bond with this oxygen, fifth carbon oxygen, and this oxygen has took this particular hydrogen. So this oxygen, which is attached to the first carbon, has took this hydrogen. Okay. So this is the first form, and a ring is formed here. I'll discuss about the ring later. Okay. And one more structure is also there. That is second structure. So what is the difference between these two structure? In the first structure, OH group is present on the right side, and the second structure is there on the left side. The remaining things are same. From carbon number 2 till 6, everything remains same. So there is a difference only in the carbon number 1. Got it? So we have two different forms. The first form is called as alpha D plus glucose. Second form is called as beta D plus glucose. Okay. So if two structures differ only at one carbon, if the two structures differ only at one carbon, then those two structures are called as anomers. Those two structures are called as anomers. So the carbon number 1 in both the structures, they are called as anomeric carbon. Carbon is named as anomeric carbon. Got it? So any doubt here? We are getting alpha and beta structures. Any doubt you have? Here in both the structure, this carbon, carbon number 1 is named as alpha. Yeah, I'll tell you about alpha and beta. I'll tell you about alpha and beta later. Any doubt you have in forming the ring using the oxygen lone pair and the attacking with that carbonyl position? So there is no doubt in the ring formation, right? Yes. I'll discuss with you about alpha and beta now. So this is your alpha D plus glucose and this is beta D plus glucose. And Haworth is the name of the scientist. He represented this cyclic structure. So this is the cyclic structure of glucose is called as the Haworth notation or Haworth structure. Okay. So we are getting a 6-membered ring here. This is number 1. This is 2, 3, 4, 5 and 6. What we are getting? We are getting a 6-membered ring, not 6 carbon containing ring. Since we have one oxygen here, it is named as 6-membered ring. And in the 6-membered ring, let me number all the carbon atoms which is there. So carbon number 1 till 5 is here, and carbon number 6 I'll show you. It will be attached to the 5th carbon. So in carbon number 1, right side we are having OH and left side we are having H. So all the groups which are present in the right side has to come to the bottom position. Okay, it has to come to the bottom position. And all those which are there in the left side to in this particular open chain structure has to be represented in the upward, okay, in the above position. In third carbon, we are having hydrogen in the right side. So it has to come down, OH has to go up. And the fourth carbon, OH is down and H is up. In the fifth carbon, listen carefully, in the fifth carbon, we have hydrogen in the left side, but it has to come down. That is an exception you have to follow, okay? In the fifth carbon, you have hydrogen in the left, but it has to be written down. And in the another side, to the fifth carbon, one is hydrogen, the other one is the sixth carbon containing system. It has to go to the upper position. Got it? CH2OH is the sixth carbon. Are you getting? So this structure is called as alpha D plus glucopyranose. This is called as alpha D plus glucopyranose. In the same way, you can get beta D plus glucopyranose also. Everything will remain same. Only the OH position will differ because those two are anomers, right? So here OH is down and here OH is up. That's all. So both are called as glucopyranose structures. So I'll discuss, since there is time up, I'll discuss about the cyclic structure with you in the tomorrow's class. Okay. So what we have seen today, we have seen about the carbohydrates, and under carbohydrates we have studied some introductory part and preparation. We have discussed there are two preparation, and the chemical properties of glucose I have discussed, and the classification and all were there. Okay, so just go through this class. Yes, Sandeep. Yes, Sandeep. Yes, tell me. Yeah, that alpha beta, this part only I'll continue this in the next class. Tomorrow's class I'll tell you. If OH is present in the bottom side, then it is called as alpha. If it is there in the up, then it is called as beta. Got it? In the cyclic structure, if you find OH in the bottom position, it is alpha. If OH is there in the upward side, it is called as beta. Got it? Clear? Yes. Okay, but I'll discuss the same thing with you in the next class. So study and come for tomorrow's class. Okay. Okay, Devan and Sandeep. Thank you so much for listening to the class. So meet you all in the next class. Thank you so much, Pa. Thank you. Thank you. Bye bye.